Hey everyone, welcome back to another episode of the LlamaIndex webinar series. And today we actually have a special workshop on enterprise RAG using Amazon Bedrock, LlamaIndex, and Ragas. So this is a really nice collaboration between all three teams. And what we're going to be able to show is how to build a RAG pipeline, orchestrate it with LlamaIndex, use models and different types of services from Bedrock, learn different types of design patterns from RAG to agents, and then also work on a proper iteration pattern with Ragas to basically help you evaluate and continue to optimize and iterate on your application. And so without further ado, passing it to Ayan, who will help kick us off, and then we'll also pass to Jithin afterwards as well. But Ayan, take it away.
Thank you, Jerry, for the introduction. My name is Ayan Ray. I'm a Senior Partner Solutions Architect with AWS. So as a solutions architect, I work with a lot of AWS partners and customers and help them move fast with generative AI. And I can for sure say that the partners and customers are excited beyond everything. They want to meet this technology head on, but also there are few common questions that they always ask us. First of all, there are so many foundation models to choose from, and they have their own API endpoints. They have their own payload. The customers ask us how to choose a model that best fits their use case. Also, since I told that they have their own API endpoints and own payload, they also ask us how can they move fast, build and deploy quickly without burning cycles of development on it. But the most important question that they always ask us is if or how they can keep their data private or secure while building generative AI applications. And that's the reason we built Amazon Bedrock. Amazon Bedrock is a fully managed service that helps you to build and scale generative AI applications. So the core value proposition of Amazon Bedrock are three. Number one is model choice. Number two is data privacy and security. And number three is customization. Talking about model choice, Amazon Bedrock offers a choice of high-performing foundation models from leading AI companies and Amazon with a broad set of other capabilities like evaluation, guardrails, and all the features that you need to build generative AI applications. Some of these LLM provider companies in Amazon Bedrock are Anthropic, Cohere, Meta, Stability AI, AI21 Labs, and Amazon. Next is around the question around data privacy and security. First of all, none of the customer's data is used to train the original base foundation models, period. And when you fine tune your model, we make a private copy of that model, put it in a secure container that is only accessible to you. All the data is encrypted, both in transit and in rest, and you can securely access Amazon Bedrock from your Amazon VPC without going through a public internet. And you can do that using AWS private link. Also, the data that you store in the S3 buckets are secured by KMS encryption. Also, Amazon Bedrock is in compliance with HIPAA. It's HIPAA eligible and in compliance with GDPR, SOC, ISO, and CSA. Some of the requirements that enterprise customers need to move their POCs to production. With Amazon Bedrock, you can easily customize your foundation models using either fine-tuning or retrieval augmented generation. And we have specific features available as part of Amazon Bedrock. And we'll cover the retrieval augmented generation part in depth in the latter part of the presentation.
Quick question from the audience. Is Bedrock available in AWS GovCloud?
Not yet, I think. Yeah, there are a few regions, but it's coming soon in many other regions. Then talking about the model choice, is the Claude 3 family of models. You can access the Anthropic Claude 3 family of models, that is HiQ, Sonnet, and Opus. Claude 3 Opus is the most powerful and most intelligent model, whereas Claude 3 HiQ is the fastest, most cost-effective model. And Sonnet strikes a great balance between intelligence, speed, and cost. All three models have 200K context window and have vision capabilities, and these capabilities are optimized for enterprise use cases. That means it is great in understanding from PowerPoint presentations, charts, graphs, etc. We also have our own models, Amazon Titan family of models. We have the embedding family of models, that is Amazon Titan text embeddings to create numerical representations of text. And you have Amazon Titan multimodal embeddings. We have text generation family of models, Text Lite, Text Express, and Text Premier. Text Lite is a lightweight model which is cost effective and highly customizable. Whereas Titan Text Premier is the most powerful and advanced model in this family. And it is highly optimized for working with agents, knowledge bases, and RAG use cases. And Titan Text Express strikes a fine balance between cost and intelligence.
Out of curiosity, if I'm building agents, should I think primarily about using Text Premier? Is it optimized for stuff like tool picking?
Yes, Text Premier will be your choice because it's the most powerful and advanced model. So for agents and tool picking, Text Premier is the de facto choice. Yeah, and Text Premier has 32K context window. Text Lite has 4K. Text Express has 8K. Moving on, discussing about the common customization techniques. Some of the common customization techniques that I'm seeing with customers are, first of all, is prompt engineering. That is architecting a well-designed prompt specific to the foundation model that you are using. Then there's retrieval augmented generation, there is fine-tuning, and continued pre-training. And this is based on complexity, quality, cost, and time that customers use either of these techniques. But one predominant customization technique that I'm seeing in most of the customers is RAG, retrieval augmented generation. So I'll quickly touch upon what is RAG. So it consists of three parts: retrieval, augmentation, and generation. Retrieval is the component which fetches the relevant content from the external knowledge base. It can be the corpus of the enterprise data. And that is done usually on the basis of semantic similarity algorithms based on the user query. Now comes the augmentation part, where we take this relevant context, and it might be the most updated context relevant to the user prompt, and we use that to augment the base prompt. And we pass this consolidated base prompt plus the augmented data, augmented context to the large language model. And then the large language model generates the response based on this augmented prompt. This is how a typical architecture of RAG looks like. And we will discuss about more advanced agentic RAG patterns at a later part of the presentation. But this is how typically RAG works, RAG looks like. First of all, there's a data ingestion workflow where we take the source documents, chunk it, pass it through an embedding model for it to generate numerical representations of that text data, which is also called vectors. We store that in vector store. Then comes the text generation workflow, which starts with the user submitting a query. The user query is being passed through an embedding model, again, to generate the vectors representing that user query, which then is passed through a semantics search algorithm. It can be an variation of approximate nearest neighbor. You can use KNN type of algorithms, cosine similarity, dot product kind of algorithms, mostly cosine similarity. You can also use hybrid search, though, over there, which combines textual and semantic searches. All of that is done to fetch or retrieve the most relevant context from the vector store, which again is then used to augment the user input. And then it is passed to the large language model, and then the large language model generates the response based on this augmented prompt. Now you can automate this entire workflow using knowledge bases for Amazon Bedrock. So knowledge bases for Amazon Bedrock is a fully managed RAG capability that allows you to customize foundation model responses with contextual and relevant company data. It automates the end-to-end RAG workflow that includes ingestion, retrieval, and prompt augmentation, eliminating the need for you to write custom code to integrate data sources and manage queries. Also, session context management is built in, so your app can support multi-turn conversations. All the information retrieved from knowledge bases comes with source citations to improve transparency and minimize hallucinations. And interestingly, Amazon Bedrock and knowledge base for Amazon Bedrock has built-in integrations with LlamaIndex. So LlamaIndex makes it easy to even work with these two technologies. Any questions on knowledge bases? Good.
One question I had was, sorry, real quick,
Yeah, sure.
the session context management for multi-turn conversations. Could you talk a little bit more about that?
Yeah, so that is where information from prior turns is retained. That is the conversations maintain a state to inform the subsequent interactions, as a result of which we get a more logical and coherent flow of the conversations.
So basically you can use knowledge bases to store not just like documents, but also conversation history.
Conversation history, yes.
Okay, cool.
I have a quick question as well.
Yeah.
When you're ingesting the data from any of the knowledge bases into the Amazon Bedrock and integrating with the models, how are you preserving any access controls those documents might have, right? So any of those sources at the source level, and when you're trying to expose this through the RAG, through a user query, do you consider any of those things and filter out if the user does not have access? And if so, how is it all done internally to preserve that access controls on the source information?
Yeah, great question. So first of all, the AWS access controls that you are generally familiar with are also applicable to Amazon Bedrock. And number two is we also have enabled metadata filtering as part of knowledge bases for Amazon Bedrock that can help you to filter the metadata and retrieve only the documents that you want to access.
Is that metadata part of the user query as the query is coming in? Let's say I'm searching for some information, and then that source, if I don't have access, does that get filtered as it is retrieved, or you retrieve everything and then you filter the data by looking at the access that you have for the data or not only, and then surface the delta and then send it to the model? At what step does that access check happens once a query comes in step one?
Yeah, so the metadata filtering is part of the user query, and also you can use IAM to just make sure the user that is doing the query has access to the right indexes and the right knowledge source.
Yeah, but I
And
would
I'm
not know, right, which knowledge sources it is going to check, right, because it's all embedded into the vector database, right, indexed. So
yeah,
you're going
I'm
against
happy
that
to.
workflow.
That's a great question. I'm happy to take
Yeah.
it offline.
Got it.
We can chat.
Yeah,
afterwards.
let's yeah, for some of the detailed questions, just for the sake of time. I see like there's also 4 or 5 questions in the chat. I'm sorry, we might not be able to get through all of these. I'll try to maybe answer some of these like offline as well. But yeah, feel free to carry on. Yeah.
Cool. Thank you. Yeah. Also, apart from our native services, AWS Partner Network has more than 130,000 partners from over 200 countries. What you're seeing on screen is a list of ISVs that has achieved generative AI competency. For example, there are partners like Elastic, DataStax, SingleStore, which are not yet part of the knowledge base. And there also, you can build RAG applications using LlamaIndex, because LlamaIndex has built-in integrations with these vector stores. You can use Amazon Bedrock and these vector stores to build RAG applications using LlamaIndex. Jerry, would you like to touch upon that about the integrations that you have with the vector stores?
Yeah, totally. And I know you have like a few slides later on that showcases some like the patterns. So we've done workshops with AWS with like some of the integrations that we have, and the core integrations that we have include the LLM. So we integrate with all the models that Bedrock supports, the embeddings as well. And then also we have a knowledge base integration. And so effectively you can treat knowledge base as like a vector store. Knowledge base, like Bedrock knowledge base, does manage some pieces of like the ingestion as well, right? So it's a bit more kind of like out of the box compared to your standard vector store. That said, you can still customize it in that if you want to like load your own documents, chunk it beforehand, like parse it beforehand. We have like a full cookbook, for instance, showing how you could use Llama parse with Bedrock. So you can basically kind of manually use the API to insert documents into like Bedrock knowledge base, and then use it as a retriever to plug into the rest of your workflow. So those are pretty much like the three main integrations right now with Bedrock. There's probably more coming soon as well, and there's probably more examples, for instance, with like Bedrock agents. But yeah, passing back to you.
Cool, thank you, Jerry. So I'll next show a quick demo of just a walkthrough of the libraries that are present in LlamaIndex for Bedrock. So first of all, there is LlamaIndex.llms.bedrock. You can do import Bedrock from this, and by that you can access LLM, Bedrock LLM. You pass the model ID, and you can use LLM.chat to invoke that model. Alternatively, if you want streaming responses, you can do LLM.streamChat to get streaming responses from the Bedrock model, from the model available in Bedrock. You can easily build RAG applications. For that, you need to install these libraries: LlamaIndex LLMs Bedrock, LlamaIndex Retrievers Bedrock, and LlamaIndex Embeddings Bedrock. Similarly, you call the Bedrock through the LLM, which you import from LlamaIndex.llms.bedrock. Then LlamaIndex, as I said before, has built-in integration with Amazon Knowledge Bases Retriever, where it is retriever equals to Amazon Knowledge Bases Retriever, and that you import from LlamaIndex.retrievers.bedrock. And that is how you ask a question, and you just retriever and retrieve, you fetch the relevant results, and you get the response out of it. Also, as I said, there are vector stores which are not available in Amazon Bedrock knowledge base. There you can use built-in integrations available in LlamaIndex. For example, here I'll use LlamaIndex vector stores Elasticsearch to show how to build RAG applications using Amazon Bedrock and Elasticsearch. There you use LLM equals to Bedrock. Similarly, you just connect to Elasticsearch store, which you import from LlamaIndex.vectorstores.elasticsearch. You create an ingestion pipeline, like with the help of you can use the simple directory reader to load the file. It can be JSON, it can be PDF, and then you run the pipeline. And the pipeline takes care of splitting based on the chunk size that you specify. You can specify a chunk overlap interval. The model here is the embedding model, which in this case I've used Amazon Titan for embeddings. And the vector store is the Elasticsearch vector store. So once you run the pipeline, it does everything from chunking, embedding, and ingesting it into the Elasticsearch index. After that, you create an index out of it, which is like vector store index, and then pass the query in a query bundle, and then you get the result by invoking query engine.query. This is how you can. This is where LlamaIndex is also an effective tool to actually navigate this entire generative AI ecosystem. Next, I'll move to some advanced RAG patterns, and I'll hand it over to Jerry. If you can take us through some of the advanced and agentic RAG patterns, which can be used also to optimize the RAG output.
Totally. Yeah, thanks for passing it over. And so for those of you who have or haven't seen like the recent course we did with Andrew Ng on deeplearning.ai, a lot of that topic was on how do you go from RAG to agents. So basically adding in some reasoning layers to go from simple question answering to more advanced question answering. And that really is the the benefits of kind of designing a more advanced like agentic query understanding layer, like beyond the standard RAG pipeline. And so I think there's like 3 or 4 patterns here that are described, and what they basically consist of they reflect like the core components we covered in the agentic RAG course. And they're basically layers of like reasoning that you can add on top of a RAG pipeline in order from like more simple reasoning to more advanced reasoning. So routing is probably like the most basic form of reasoning. Where basically, it's an LLM call. You could probably implement it yourself if you wanted to, with like structured outputs. You just take in a query, and then given a set of choices, just pick one choice or multiple choices. That's it. That's like the main responsibility of it. And so a router will just take in the query and route it to the relevant underlying choice that best reflects where the query should go. And so there's a few different use cases for it. In this context, it's basically picking the best query engine to help answer your question. And this matters if you have like different types of questions, some of which might require different types of retrieval, whether a document level retrieval or a chunk level retrieval. You can route it to different agents that are responsible for different like retrieval strategies. You can also do some sort of like routing to like if you have different pipelines owning different parts of your knowledge base, routing it to the right query engine of your knowledge base. So that's an example of routing. If we go to the next one, it's basically some sort of query like rewriting layer or query decomposition. And so, this like basically takes in some sort of input question, and if it's very complex, we'll break it down into simpler questions. This is like a core ingredient in basically any sort of agent that you would implement. It's pretty much it's present in most agent papers in some form. So chain of thought is an example of this. You take in a question and break it down into what the next step should be. You can also like take in a question and break it down into a set of subtasks that you can parallelize instead of just doing like one step at a time. Like break it down into like a set of 4 steps, like query 1 through 4, and just like try to ask all of them at once, right? And so like that, the sub question slide is basically almost like a subset of like query understanding, where this is an abstraction in LlamaIndex called like the sub question query engine, where we take in a question and we could break it down into basically parallelizable questions that we can launch in parallel and aggregate the responses in the end. And so these are all kind of like components by components, right? And a full agent ideally should be able to do everything. It should be able to like break stuff down into parallelizable components and also chain them together into some sort of plan. The advantage of just using the component instead of the full system is typically much faster or lower latency and lower cost, because you're trying to use like a more focused module as opposed to like a general purpose agent, which typically consumes like more tokens. Anyhow, so like the use case for this is like if you have a pretty complex question, like what's the revenue of Uber, Lyft, Apple, Tesla, and you want to ask that question, you need to break that down into 4 sub questions, like what's the revenue of Uber, what's the revenue of Lyft, so on and so forth. And each small chunk is much easier for a RAG pipeline to answer than trying to answer the full question at once. If we go next. And so like once you actually combine some of these ingredients into a full agent, then you basically get back, for instance, like different types of agent implementations. And a very classic one that many of you probably already know is this idea of like a React agent, which just generates like sequentially what the next step should be given like your prior observations, as well as like a set of tools that you have. Tool picking is basically like a superset of like routing, where instead of just like picking the right tool, you also infer the right parameters for the tool. So given some sort of like task or input or question, and given a set of tools, decide what tool to use, but also like the input for that tool. So usually each tool contains some sort of function signature or API spec, and given the agent's knowledge of that API spec, it can infer the right parameters. And so that's the third ingredient in being able to construct an agent. And you can use that by itself in LlamaIndex, or you could use that as part of like a React agent. And so Ayan kind of showcased this overall flow if you do use it as part of a React agent here.
Thanks, Jerry. So we can
Cool.
jointly walk through a demo of the React agent, a RAG pipeline using React pattern. Similarly, like we call the Bedrock model using LLM. We use the embed model, connect to Elasticsearch. Here I've used Elasticsearch as the data store. I downloaded 2 files, Lyft financial report and Uber financial report, and all these are available in the LlamaIndex repo. Then we use a simple directory loader to load it. Then we have set the environment variables like LLM, embed model, chunk size. We pass the vector store as a storage context and then we load the documents in the vector store. Now we have 2 separate indexes, one corresponding to Lyft, the other corresponding to Uber. Then what we create a query engine corresponding to each one of those, Lyft index.as query engine and Uber index.as query engine. Then we create the query engine tool, and there it's an array of tools. One tool is for provides information about Lyft financials for year 2021, and the other one provides information about Uber financials for year 2021. And then we create our React agent using LlamaIndex.core.agent, import React agent. And then we query with the React agent. So if you see agent.chat, what was Lyft's revenue growth in 2021? So it is giving it a thought. The current language of the user is English. I need to use a tool to help me answer the question about Lyft's revenue growth in 2021. The action, it refers to Lyft 10K. Which is the name that we passed in as a metadata. Then the action input is what was Lyft's revenue growth in 2021. That's the question that you passed. Then it has an observation. According to the information provided, Lyft's revenue is increased by a certain amount, and it observes, it understands what's happening there, and then it gives a thought. I can answer the question using the information provided by the Lyft 10K tool, and the answer is this. And then when I do response.response, I get the response, which is the answer over here. So it goes through this thought, action, observation, thought, and it can also go through multiple passes of it. Like, for example, I am now giving an example where the overall behavior of the system emerges from the interaction of its parts. For example, compare and contrast the revenue growth of Uber and Lyft in 2021, which resides in 2 separate indexes. It can also reside in 2 separate data stores in the enterprises. Again, it goes through the same process: thought, action input. But now it gives another thought, like I now have the information on Lyft's revenue growth in 2021. To compare and contrast with Uber, I need to get Uber's revenue growth information as well. That's when it goes to this tool, Uber 10K, again retrieves that information. Then what it generates an answer, which is a combination of both the tools outputs, and then it generates the final answer. So when you get the final response, it has actually used both the tools and has compared and has interacted. Both the tools have interacted with each other to generate an overall response. Jerry, you want to add something to it?
No, I think this is a good overview. And I think the other thing is you can also look at like sources. So we basically propagate and append all the sources throughout the responses as you like all different tools.
Yeah, I think these are some of the code samples, which might help you. So I've generated QR code for this, and I'll make sure to upload commit all the code that I demonstrated. So this is a repo I maintain, AWS Generative AI partner samples. and all the code that I shown will be available in this repo by end of the day today.
And sorry, go on.
No, just I was saying that's it from my side. Thank you.
Cool. And just to actually, I was kind of thinking about it, like in terms of just some other quick things to add is the demo here is on like the React agent. So we do have other agent implementations. I think basically any LLM that supports native function calling, a simple thing you do instead of explicitly the React prompt is just do a while loop through the function calling API. And so we have like a function calling agent. Those two are probably the most simple ones for you to get started with. Those are good baselines that you should probably use instead of some of the more complex ones. We do have more complex implementations like LLM compiler. There's another one that I forgot. Like there's like a structured planning agent, like a bunch of like implementations based on like different papers. All of those are, to be totally honest, less reliable, but more interesting, like fancier from like a paper perspective. And it's just because like right now it's one of those things where like sometimes simpler is better, given that the models there's still some gap in making them like fully reliable for agentic workflows. So we do have those other agent implementations on Llama Hub if you want to take a look. You can also write your own custom agents by just subclassing like a very simple wrapper we give you and writing your own Python code and logic. And yeah, maybe I'll link that in the chat. But anyhow, yeah, passing it to back to you.
Yeah, so thank you. I'd pass it over to Jithin to cover about Ragas.
Right.
Hey guys, let me share screen. Okay, we should be good. So, I had said, like Bedrock is something that is very, very like relevant if you are an enterprise, because most of the time you have like other like serious requirements regarding your data, privacy, and stuff like that. So Bedrock makes a very good case. And one thing that you're out like when you're developing LM applications, one main concern with that both managers and developers have is, hey, is it working the way I wanted? If I make a small change, what happens? Are my users like actually like making sense of it for different outputs? What are the ways my application reacts, and all these things regarding testing and ensuring the quality. So I wanted with Ragas is like an open source evaluation framework for LM applications, and I wanted to showcase something that we have been working on for the last 1 week that enables this workflow if you are someone who's using LlamaIndex and Bedrock. So on a high level, like the importance of evaluation cannot be like I have to like emphasize, because what I have seen like again and again, like as a maintainer of like this open source project and talking to a bunch of customers, is that every team that has a very good evaluation, it's not like different on Raga. Every team who is very serious about having an evaluation strategy and actually puts effort into that gets a lot from that experience. And especially in today where like every company is actually experimenting with LLMs, right? And the field is like moving fast, like things a lot of things are changing, and in order to keep up with this rapid field, having a very good evaluation strategy makes a lot of sense. This is something that Hamel advocates for, and he has written a very good blog post that covers the whole thing end to end. And the essence of that is that if you iterate, the more you iterate, the faster that you iterate, the more you can learn, and that equals to success. So something that we as a Ragas like project tries to like explore and like answer is that, okay, how can we use models as co-pilots for like evaluating and testing your LM application? And that is the whole side of the project. So today we have two pieces. One is an evaluation piece, which gives you like a solid set of metrics to like evaluate various different parts of your RAG pipeline. And we have a tested generation piece that you can use to test, like synthetically generate test sets that we cover various different things. So one of the most requested feature here was like adding support. We used to have this until we like did a revamp with 0.1. But today I'm like happy to announce that we with the release of 0.1.9, which I just did a few hours ago, we have full support for LlamaIndex and Bedrock. So the main thing here is that okay, we have an evaluate function that works with query engines. We have modified the test generation feature that generates tests with LlamaIndex documents, and we have some LLM wrappers for LLMs and embeddings. So in the next like few slides, I'll just show how it works. We also have a documentation site up and running, so you can check that as well. But I'll just give you an overall high-level overview, and then we can take questions for that. So basically,
Jithin,
the first thing,
really quick. Just a heads up, your mic is a little vague right now. It's a little like can be a little bit hard to hear. But yeah, it's okay. I can edit this part out of the video, but just curious if you have like an alternative.
let me just check if I have something. So I don't have another option. I just talk loud.
Okay. Yeah, no worries. Maybe just like speak like slower and louder, and then we can see if that works. Yeah.
Okay. Cool. Yep. So the first thing is the evaluation option, which we use to like evaluate various different components, various different metrics that you can use. So you can use faithfulness, which measures like hallucinations. You can use the relevancy, and you can also use like context recall and context precision, which is something that is very important because what we have seen again and again is that most RAG pipelines, the thing that you have to optimize for is the retriever, because that is the one that gets like it does a lot of easy wins there. And using context recall and context precision is very good when you're improving the retriever part. So with if you like most of the users who like they want to prefer using an LLM for evaluation, which is the same as the one that they're using for LLM application. So if you're using Bedrock, right now you have easy access using Bedrock within the whole LlamaIndex plus Ragas setup. And I would always recommend using the largest model that you can. So here I'm using Sonnet for doing the evaluations, and then you can set it up easily. So the first part is always like fixing which LLM you use, and here I'm using Sonnet, and then the second part is also building the query engine. So the evaluate function takes different query engines that you can experiment with. So you can build a query engine with different embedding or a different query transformation, and build a lot of different query engines that you want to try. So always you build a baseline, and then you try various, like you change one thing, and then you evaluate that with Ragas. So you build the query engine, and then you pass it over to the evaluate function along with the metrics and the data set and the LLMs that you want to use, and then it will give you the result. So that is it for evaluation. And for test generation, it's the same thing. But here, like the first thing, as like previously, is choosing your LLM. So here again, I'm using Sonnet for both these things. But one thing to note is that okay, we have a generator and a critique option. The generator model's responsibility is to generate the final answer in the algorithm, while the critique model is responsible for like critiquing and making sure that the generated answers and the generated questions and the notes that we take are of high quality and meet the spec that we need. So it's always recommended to use a critique model that is much like as powerful as you can. And then the generator model is you can use a haiku model here because it makes sense if it makes sense for you as well. And then you once you fix the LLM, you can easily create the generator and then pass it over to the generate with LlamaIndex option, and then build the test set. So,
Jithin, quick question. For the test set generator, how do you like? I'm assuming you do something where like you try to generate like a set of like questions and like ground truth, I guess, for each like chunk or something. How do you think about like generating more complex questions that span like multiple documents or multiple chunks?
Yeah. So for that, so here you can see that we have like options for reasoning and multi-context questions. So the how we operate on that is like based on a paper called like it was the Wizardman paper, but they talked about evolutions where you generate a simple question and then you evolve the question into more complicated stuff. So how this works here is that we'll take all the documents that you load with your LlamaIndex document loader, and then we like do one pass on it to chunk the documents and figure out the various different chunks, like based on any chunking strategy that we decide. And then it's like the test generator arbitrarily chooses one node that is of higher quality. Here we use a critic to ensure that the node is in fact of higher quality. Where like if the chunk is say from the content page or from the appendix, it might not be as meaty to generate like high quality questions. And once you have fix a context, you generate a simple question that could be just like a very basic question, which LLMs by like if you ask an LLM directly to answer like to like generate a question, it will generate a very simple types of questions. And that was the fault that we were trying to solve with this tech. So we use that first simple question, and then if the problem is to be like if it's a multi-context question that we want to generate, we check the answers, like we check the similarity score with the selected node, and we try to get the top 3 nodes that are like have similar, like are semantically similar. And then with these we like join it together with the chunks, and then we try to like generate a question, like we try to evolve the generated question to make sure that this is a question that can now only be answered with the 3 semantically similar like semantically similar nodes. So that is how
Gotcha.
like, yeah, first we generate a simple question, and then we do some permutations to generate harder questions. So that is reasoning also follows a similar logic, but in general, that's the approach.
Cool. Yeah, it makes sense. I wonder if you could even do something like more fancy where you take like disparate clusters and try to generate like kind of multi-part questions that ask between like things that aren't similar. But yeah, no, I feel like the space could get pretty complex.
Yeah. Like one thing that we are also like exploring right now is okay. So this is good for like generating like some sort of like easy questions that are a bit more harder than if you directly like ask an LLM. But so there is a bit of challenge. But ultimately, what users want is to generate questions automatically that match your production data sets, and like what your like match the type of questions and queries that users are asking. That is something that we are working towards in the next like release. So we get something once that's up.
Yeah, that's cool. Makes sense.
Yeah, and yeah, this is the documentation. Docs are up, so you can see that. And since the release is also up, you can like you should try it out. If there is any issues or like feedback, do let us know. And that is it.
Cool.
Yeah, if you have any questions, yeah, I can use this for the discussion.
No, this is great. I think maybe one. I mean, I think I have a bunch of questions about evals, but we can kind of see we can basically like rotate through, kind of ask a few questions, like get your thoughts, Jithin, and also Ayan, in terms of like what you've seen. The first question actually about evals is so yeah, Ragas is I mean, you know, you guys are pretty well known in the whole like eval space as like I think you've done a really good job of becoming this like single metric that like people can just use to evaluate their model. Do you think that for most people building like these use cases that they should have like a single metric that they should also try to define their own custom metrics that are specific to the use case, or both?
Like from like a framework point, what we can actually do is like ensure that there are like like ensure that like metrics, there are some metrics that everyone uses, but there are users who like have very custom like use cases, and that they go ahead and generate their own like metrics. So one thing that we want to like try and work is trying to make sure that that process becomes easier. But yeah, that's a fine line that we have seen. So, so for example, like if you are improving the retriever, which is like a very high level, like objective, then having like recall and precision measurements makes sense, and then Ragas provides that out of the box. But some like metrics that we have seen is refusal rate, or like very like um, very niche thing that only matters for your product, and users like will develop their own metrics for that.
Yeah,
that makes
one
sense.
example. Yeah, just to add to it, one example that I've seen, some users use Ragas to develop custom metrics, and that was like bias calculator, right? Evaluate if the response is biased. So that's one thing that I've seen.
Yeah, that makes sense. The next question is for both of you. Should developers generally start when they think about like building stuff and then evaluating and iterating on their application? Should they start by building the whole thing and then just like testing the whole thing first, or should they build and test component by component? Like if you're building like a agent or RAG system, do you start by just like building the entire thing and then kind of like roughly seeing if the whole thing works, or should you test like bit by bit? Maybe Jithin, I'm curious to get your thoughts first.
So definitely end to end, like because it is, it feels brittle, but it is the easiest to like get started with. So whatever like which you get started, that is good to go. And what we have seen is that you actually like, so one metric that we have is answer correctness, which is like an end-to-end metric. We're given a question and a ground truth. We just like compute if the answer is correct or not. What we have seen is that users get a lot of value if like the limiting thing is the test set. Like you have to have a good test set. So if you have a good test set, even having like a very simple like answer correctness method, this end to end, gives you like helps you, like it's like a cushion that you can rely on when you're like rapidly changing your product. So yeah, just whatever the easiest like end to end answer correctness is like a very easy metric. There is a lot of like use that you get out of that. So,
Yeah, I echo that. So the approach that I've seen is first, the developers create an end-to-end pipeline, right? Generate a response that serves as a baseline. Then, then they study the metrics, say, for example, context precision and context recall. And they now understand, hey, there's a problem in the retrieval step. And then they go and say, maybe tweak the chunking interval, use semantic chunking or things like that, or maybe use re-ranking and see how is it performing as compared to the baseline, and then continue iterating over it.
Gotcha. Yeah, that makes sense. So kind of like, I mean, I guess a lot of like also what Ragas has is kind of like being able to evaluate the final response. And so you are able to do that almost as like a first pass and then go in and see what the specific components are. So you dive in like more deep afterwards. Yeah.
Yeah, something else that might be useful. So like end-to-end test, you need a ground truth, right? So there are like also reference P matrices that like, so for example, refusal rate or biases, like Ayan mentioned, like those kinds of metrics also give you like some sort of like signal. There when the limit is that okay, do you have enough like compute to or like money to actually like burn to like get those insights. So that's also like just having those metrics as like lives or something that you can track. We have seen users who get a lot of there, whereas if there's a dip in one metric, they see that okay, that is something that you have to worry about.
Yeah, and in case the users do not have a ground truth, you can use the other feature that you have launched to generate. You can feed in a document and it can generate the question, answer, context, and ground truth in that format. So that will also be really helpful.
Can I ask a question?
Maybe then oh yeah, go for it. Also, if you have a question, let's maybe put it in the chat first. But yeah, go for it, Asad. Yeah.
Okay, no issues. So what exactly I want, because I'm making a high level RAG with around say around 300 PDF documents. So it is a RAG on a US public database. So I deployed this Ragas on this, and it didn't work on that for that level of data. It was giving me broken key question answer. I mean the pairs, key value pairs actually. So I was pretty hopeful that I could get a good response as far as the evaluation is concerned, because right now there is and Prometheus 2 gave a good response. Just I'm not actually criticizing things, but this is what because I work in a production environment day in and day out. So not a Google Colab type of environment in which I do something, and that is just for LinkedIn purposes. So for production, I have been trying to evaluate various methods for evaluation of RAG. It is working, Ragas is working for small chunk of data, but for huge corpus of data, it is not working. So like I have to build an advanced RAG, say from data starting from 2010 to 2024. So this is the chunk. So it is not working on that because I deployed GPT-4 to generate that context and all those parameters which are mentioned there. It generated the questions, it generated their answers, but uh, many times they're broken in between. So any solutions with that? Any ideas? I can go ahead with that.
Yeah, so that is actually like one of the limitations of the test generation module that we have. It was not it was not intended for that scale, which is like more of like, okay, can we get this like going? So now we are working on a revamp. So if you actually like give me your email or something like that, we can like contact you after this and then we can talk after that. But yeah, that is one of the limitations that we have with the test generation feature. We are working on an improved one right now. So like your feedback would be really useful.
Yeah, absolutely. I would love to connect, and I'm desperately searching for a RAG evaluation framework. And I don't think so. Pretty much many of them which are available in the market are production compliant.
Yeah.
Many
Yeah.
would,
So
Yeah,
that
I think. Oh, sorry.
the
No, Jithin,
long
go on.
tail to the long tail to getting evaluations is like a bit tricky. So like there's like a lot of considerations like, okay, what are the domain that you're working on? Does these prompts work for the domain? Then you have to adapt the prompts for that domain. Things like that are like active problems that we are also like are aware of, and we are like working towards it. But please do give me your like email, and we can like I would love to take this conversation. Okay.
yeah, sure. Should I
Yeah.
give it?
Yeah.
Yeah, just drop it in chat.
Great. Yeah. So yeah, I mean, obviously Jithin and the rest of the Ragas team is working hard on trying to create like production quality metrics, evaluations for being able to evaluate RAG pipelines and also beyond as well. So they're probably in the best place to do it. The next question that I had was actually maybe to Ayan first, and this is something that I'm just curious about. Is like, do you like? We've personally seen that a lot of enterprise applications are actually in the POC stage. Where there's like some sort of gap in transitioning from POC to production. What are your typical like recommendations? Like, what are some like common pitfalls or that you've seen and kind of like patterns that you recommend to users to basically kind of make their application like RAG or anything else like agents more production ready?
Yeah, sure. So it's as Jithin was saying, there's a long tail, but there are a few common things which always stand out. First of all, which is not technical, which is more business centric, is that generative AI is cool, but we should not treat it as a magic wand solution for everything. First of all, we should evaluate if it is a generative AI problem or not. Then there are on the technical front, one of the most common things that restricts from moving POCs to production is the entire question about privacy, security, safety, and compliance. We at Bedrock handles this ground up, we like the techniques that I mentioned around the integration with private link, KMS encryption. We take privacy and security as a priority 1 or 0 for us. We also have guardrails. We are probably the only cloud provider to have implemented guardrails on Bedrock that can restrict from giving out from the LLM restrict the LLM from giving out responses which are toxic or harmful to a particular community. So that really resonates well with the customers. And there's few things, right? When we start evaluating the RAG applications, we find problems in various places. One thing I was mentioning was that chunking. Chunking presently, if I use a chunk interval, a fixed length chunk interval, sometimes it abruptly cuts in between where the meaning of the sentence is not preserved. There I have seen at times semantic chunking really helps improve the performance. Then there are cases where we retrieve the context. We apply semantic similarity algorithm, hybrid search, but then the context might not be relevant to the question that has been asked. So at times, what we also have seen that we use a re-ranking technique. Obviously, we can only apply re-ranking where in applications which are not so latency sensitive. Then we apply the re-ranking, re-rank that, and basically, break down our one phase retrieval to two-phase retrieval, and that has resulted in improvement of the eval scores. So these are some of the things that I'm seeing.
Jithin, anything else you want to add to that? I think the semantic trunking, re-ranking parts make a lot of sense.
Yeah. And then like query transformers also like is one thing that has been like very impressive, like has been getting like a lot of good results as well. But mostly, yeah, like also like cleaning data is like one very like making sure that your chunking strategy is like very correct. You are making like formatting the data in the right way, and like Llama Pass and tools like that make it like super easy for that. So, yeah, those are some.
Sweet. I think we're basically wrapping up and almost out of time. I know there's a bunch of questions in the chat that we didn't quite get to, but hopefully we responded to a bunch of them offline. But some of them, of course, like we might have missed. First of all, I just want to say thank you so much, Ayan and Jithin, for the time in preparing the slides and the resources. Please, let's make sure to share, or you can share them into chat, but also like we can try to publicly like share this online as well. So we'll have a YouTube video, out, and then we'll also share this on our Twitter. And so you'll have all the resources you need to basically build enterprise RAG with, Bedrock and Ragas, and basically have like a principled development framework to build like production RAG. So yeah, and thank you all for your time. And we'll link the resources soon. And hope you have a great rest of the Thursday.
Thank you. It was a pleasure.
Yep, thank you. Yep, likewise. Thank you, Terry.
Thank you.
Thank you.